All right, welcome everybody. We are going to be talking about the properties of water today. So our properties of water. All right, water is a polar molecule, which means the electrons are unevenly shared. And a lot of this today should probably be this slide a review from either chemistry or IPC. So again, water is a polar molecule, electrons are unevenly shared, which gives water a bit of a charge. The oxygen is slightly negative because it has more of those negatively charged electrons, and the hydrogens are positive. Because of those charges, water forms what's called hydrogen bonds. And that's when the negative oxygens from one molecule are attracted to the positive hydrogens of another. This causes a variety of features, things like cohesion, water molecules sticking to themselves, think like a water droplet. Adhesion, when things can stick, or when water sticks to things, like condensation of a side of your glass. Surface tension across the top of a body of water allows insects to walk across it. And capillary action, which allows water to be pulled along small tubes, very important for plants in order to get water up from their roots to their leaves. That polarity also allows water to be the universal solvent, meaning that it can dissolve lots and lots of different things. It can dissolve both polar and ionic compounds. Then we have the density of water. Density of water at standard room temperature is 1 gram per milliliter. That's going to change with salinity. As salinity increases, meaning more salt, the density will also increase. They both go up together. Temperature is an inverse relationship. As temperature goes down, the density increases until we reach freezing point. But generally speaking, the colder it is, temperature goes down, the more dense. If it's hot outside, water is less dense. Think water vapor. Water vapor is really hot. The one exception on the temperatures is when water reaches the ice, freezing. Those hydrogen bonds actually begin to push the molecules apart to form a lattice structure. Water does not want to be that close to each other. And so ice is less dense, which is really unique, not the case in most liquids. And then water also has high specific heat of fusion, and heat of vaporization. What that means is that it takes a lot of energy for water to change state, either from a solid, a liquid, or to a gas. Because of that high energy need, it allows water to exist in all three states in the environment at the same time. If it's a hot, humid summer day and you have a glass of ice water, you've got water vapor in the air, you have liquid water in your glass, and you've got solid water in those ice cubes in your glass. So on to some buoyancy. These unique properties, especially density, play a role in when objects are buoyant on a body of water. Our definition of buoyancy is it's an upward force that a fluid, in this case water, exerts on an object less dense than itself. It's closely related to density because the denser a liquid is, the more it can support. Buoyancy is very important for boats and things being able to float. A lot of our boats nowadays, think about big military ships, aircraft carriers, even large research vessels and fishing boats. Big things made out of metal that would normally sink. However, due to displacement, and the boat having air inside the hull, inside the main portion, the boat becomes less dense and can float. And because salt water is denser than fresh water, it's actually easier for a boat to float in salt water. And one last unique feature of water is the hydrostatic pressure. This is the pressure that builds as you go deeper in a body of water. It's the pressure at a given depth in a liquid as a result of the weight of that liquid pushing down on the object. Here in the pictures, we see some styrofoam cups. The after is after this cup was taken down a few hundred meters into the ocean. That styrofoam compressed due to all of the hydrostatic pressure. And we won't watch it now, but you do need to go and watch this Amoeba Sisters video to finish up your notes for today. Where'd my mouse go? There we go. All right. And that is the end of our notes. So again, make sure you watch this Amoeba Sisters video. Link is in the PowerPoint.